Welcome to Two Projects. In this video, we are going to explain about a project titled Machine Learning for Email Spam Filtering Review Approaches and Open Research Problems. The project aimed to address the persistent issue of email spam by exploring the effectiveness of different machine learning algorithms and review and evaluate for their potential in accurately predicting and filtering out the email spam. The project emphasized the significance of combating the spam and recognized the valuable role that machine learning plays in mitigating this problem. The objective of this project is a comprehensive review and analysis of various machine learning algorithms for the purpose of email spam filtering. By utilizing the spam-based dataset, the project aims to access the performance of algorithms like SVM, random forest decision tree, CNN, KNN, MLP and of others, considering the important metrics such as accuracy, precision and recall. Furthermore, the project aimed to identify and address the existing research gap in the field, offering the valuable insight for future advancement in email spam filtering techniques. The requirements of this project are hardware requirements, operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement, Python IDE with version of 3.7. And these are the modules that are developed to build this project. The first module is upload the spam-based dataset. This module enables the user to upload the spam-based dataset, which is commonly used dataset for email spam filtering research. This dataset contains a collection of features extracted from mails, including the word frequency and other characteristics. And the second module is pre-process the dataset. In this module, the dataset is processed to ensure it is suitable for training the machine learning algorithm. This also involves the tasks such as removing the duplicates, handling the missing values and normalizing the data. And the third module is run KNN, naive-Bayes and multi-layer perceptron algorithm. This module involves training and evaluating the machine learning algorithm such as KNN, naive-Bayes and multi-layer perceptron on the pre-processed dataset. The algorithms are applied to classify the email as spam or non-spam based on the features extracted from the dataset. And the fourth module is run SVM, decision tree and AdaBoost algorithm. In this module, is similar to the previous module, focuses on training and testing the SVM, decision tree and AdaBoost algorithms. And the fifth module is run random forest and CNN algorithm. This module involves training and evaluating the random forest algorithm, which is an ensemble learning method, and a convolution neural network algorithm, which is particularly effective for image-based classification tasks. These algorithms are applied to the dataset to predict the spam emails. And the sixth module is accuracy comparison graph. In this module, the performance of the different machine learning algorithms is compared based on their accuracy. This accuracy comparison graph provides a visual representation of accuracy achieved by each algorithm, allowing for each comparison and identification of most effective algorithm for email spam filtering. And the seventh module is recall comparison graph. This module focuses on comparing the recall scores of the machine learning algorithm. Recall measures the proportion of the actual spam mails and that correctly identified as spam. The recall comparison graph helps the access the algorithm ability to correctly identify the spam mails and avoid the false negatives. And the final module is precision comparison graph. In this module, it compares the precision code of the machine learning algorithm. Precision measures the proportion of email classified as spam that are actually the spam. The precision comparison graph provides the insight into the algorithm ability to avoid the false positive and accurately identify the spam mails. The execution of the project. To execute the project, first we need to open the code folder. This code folder consisting of different files. The spam-based folder, it is a data set consisting of the spam-based data and documentation. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project, and the spam filter and test are the two Python files. And now to run the project, double click on run.bat file for the execution. And this is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Spam Based Dataset button. Here, by this, we are redirecting to the Spam Based Dataset folder, and here I am selecting the Spam Based Data and click on Open button. Here, we can see the graph as of Spam Based Data is loaded, which consisting of these files. These columns and rows were 4601 of rows and 58 columns within it, and then click on Pre-processed Data button. By this button, we are reading all the values from the data set and then splitting the data into training and testing part. And it gives the total spam and non-spam records found in the dataset is of 4061, and the splitting dataset into training and testing part. Here 80% of dataset is used for training and 20% of dataset is used for testing, where the training record is of 3680 and testing records is of 921. And then click on Run KNN Naive Bayes and Multi-Layer Perceptron Algorithm button. Here, these algorithms are generated by using the pre-processed dataset, and it gives an accuracy, precision and recall for each algorithm as like of this. And here for all these algorithms, the perceptron algorithm gives of maximum accuracy compared to the of KNN and Naive Bayes. And then click on Run SPM Decision Tree and AdaBoost Algorithm button. And here this SPM decision tree and AdaBoost algorithm is generated by using the pre-processed dataset, and it giving a precision, recall and accuracy of like this. And by these three algorithms we can see of the AdaBoost used of most accurate one. And then click on Run Random Forest and CNN Algorithm button. Here, the random forest and the CNN algorithms are generated by the pre-processed dataset, giving the precision, recall and accuracy as of like this. And then click on Accuracy Comparison Graph button. Here, this is a bar graph where x-axis represents the algorithms we used in this project, and the y-axis represents the value of each algorithm accuracy that is attained in this project. And click on Recall Comparison Graph button. Here, this is a bar graph. X-axis represents of the algorithms we used in this project, and the y-axis represents of the attained value for each technique of recall. And then close this graph. And then click on Precision Comparison Graph button. Here, x-axis represents of the algorithms we used, and the y-axis represents the value assigned for the each algorithm of precision. And then close this graph. Finally, I conclude that in this project, various machine learning algorithms were examined and evaluated for email spam filtering. Through experimentation with spam-based dataset, performance metrics such as accuracy, precision, and recall were assessed. The findings provide valuable insight into the effectiveness of different algorithms and highlight the areas for further research and development in the domain of email spam filtering, contributing to improved spam detection and prevention.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.